Okay. Okay, so letter G. So U-substitution, right? U-substitution is really besides the power rule, is the only strategy, technique we have for antiderivatives. We don't have a quotient rule. We don't have a product rule. We don't have a chain rule. We don't have those things we use for derivatives. We have product rule. So if I can use the product rule like you guys did on the quiz last week, use it. If it's a different type of problem, I have U-substitution. Okay, those are the two tools that I have. Okay. All right, so the first thing, we don't have a quotient rule, right? We don't have a quotient rule for antiderivatives. So the first thing to do is write it so it's not a fraction. Write it so it's not a fraction. So we have x times 1 over 2x squared minus 1. And that's going to be to the 1/3 power. Okay. I still have a fraction though. So to change that, I'm going to change it to x times 2x squared minus 1 to the negative 1/3 power. Okay, says the same thing, but it doesn't have a fraction and it's got powers instead of roots. We want to change out roots to powers. We want to, if we can, get rid of fractions. I don't like, not get rid of them, but write them differently, rewrite them. So now we got this guy. So we have two options for U-substitution. We can make x u, or I can make 2x squared minus 1u. Again, here's how to tell. This is the easiest way to tell which one's u and which one's not. If I were to pick something for u, we want the derivative to be also in there. So if I pick this guy for u, the derivative is just going to be 1. 1, I don't really need a 1 in there. But if I were to pick this guy as the derivative would be x, right? 4x, but it would be x. That guy's in there. That's the one where you know that's more than likely the one you're going to choose. And if you don't choose the right one the first time, just redo the process. Okay? So u is 2x squared minus 1. The derivative of that is 4x dx. Solve for dx. Done. Now you're ready to substitute. We did our u part. Now we're ready to substitute. Anywhere I see a 2x squared minus 1, I'm going to write a u. I'm going to write u. So in there, I'm going to write u. And then anywhere I see a dx, in its place, I'm going to put 1/4 x, or 1 over 4x du. So it's just swapping. X is going to stay. I can't move it to the front since it's a variable. If it was just a number like 1/4 or 2 or something, then I can move it to the front. But it's a variable, so I have to leave it there. This becomes u. And dx becomes 1 over 4x times our du. So this guy became this guy. And this guy became this guy. U-substitution. Okay, it's just U-substitution. All we're doing is substituting. Thanks. Okay. All right. So now we look at what we got after we substitute. anything x related, we want to go away. I don't want any x's. I just want u's left because I can't antiderivative u's and x's. Okay? So, since this is divided by x and this is times x, they go away. They make ones. So now I have 1 times u to the negative 1/3 times 1/4 du. I can multiply these guys and move them forward. So when I do that, I just get 1/4. Okay. Now antiderivatives. Antiderivatives. So u, if I add a power, that's going to be 2/3 power. And then I'm going to divide by 2/3, which is the same thing as multiplying by 3/2 plus c. So that becomes 3/8. I move u back in. U was 2x squared minus 1. Okay. Same steps. So the hardest part about U substitution is the beginning. The two hardest parts in my mind about U substitution, which I've seen over the years for students, is first of all, looking at that thing and being able to change that to look like that. That's the first part. Changing this to look like this. That's the first hard part. If you can do that, you're ahead of the game. The second thing is choosing which one is U. Which one's going to be U? I don't know which one's going to be U. That's the second part. That's the hardest. Once that happens, then it's just, okay, find the derivative, plug it back in, do antiderivative, plug it back in. That system, that is not, I don't find that students struggle with that part as much. It's, how do I start? Okay, how do I start? Which is why I'm giving you a lot of these types of things. Let's look at letter H, next page. There's a lot of stuff with fractions on here. I did that on purpose because I wanted you to, because the first instinct is, oh, let's use quotient rule. But we don't have a quotient rule for antiderivatives, so I have to use something different. Okay? So again, the top here is 8x times this guy to the power, right? And they're both divided by 3. So I'm going to rewrite it as 8x over 3 times 8 minus 3x squared to the 1/3. I'm kind of taking it apart, deconstructing it. I can go further than that. I can actually do this. 8/3 times x times I can take it apart. Is that necessary? No. But sometimes people like to do that because then you can move 8x. It's separated from x. Now you can do that. I can do that because it's multiplication. It's 8 times x. If it was 8 plus x, I couldn't do that. But because it's multiplication, you can do that. You don't need to do that. I can solve it like that if I want to. That works. But just showing you that there's two different ways to do it, how to break it apart. Because like I said, that's the biggest part. One of the hardest things about this is how to break things apart so that I can use U-substitution. Okay? Like I said, it doesn't matter to me which one you use. They're both the same thing. One of them is just more broken up than the other. Okay? So let's say you do this one. Okay? So I have two options for U. I have 8x divided by 3. And I have 8 minus 3x squared. One of them could be U. One of them is going to be U. The other one's not going to be U. Okay? Usually pick the bigger power. Like I said, pick the bigger power. Because if I were to take the derivative of this guy, it's going to be x. Because the derivative of x squared is x. That guy's in here. Right? That's usually the guy to start with. That's usually the guy to start with. Okay? So we'll go, let me see. So U equals 8 minus 3x squared du equals negative 6x dx. Okay. Solve for dx. Bless you. Okay. U part is done. Now the substitution part. So now what I'm going to do is everywhere I see an 8 minus 3x squared, I'm going to plug in U. So this guy is going to be U. Everywhere I see a dx, I'm going to plug in this guy. Okay, so 8x over 3 U 1/3 1 over negative 6x dx. Or sorry, du. I only want u's. I don't want x's. So x's I want to go away. Well, those divide to make 1. So now I have 8/3, negative 1/6. I can move those to the front because those don't have variables anymore. So I have 8/3 times 1 over negative 6. Add a power, I get 4/3 plus c. Divide by 4/3, which is the same thing as multiplying by 3/4. So I'm going to multiply. Multiply fractions, you just multiply straight across. So I'm going to get 24 over, wait, I can simplify this a little bit so I don't have to multiply as much. 3 divided by 3 is 1. 4 goes into 8 twice. So I get 2 over negative 6. Negative 2, 6. Put U back in. Negative 1/3. Done. Okay. Okay. Let me see the next one. So I want you to try another one like that. I'm going to put another one down here. Kind of a separate problem. I want you to try one like that on your own. Okay? So I'm going to give you one to do right now before we go on to, because the next one is trig, back to trig. So before we go back on the trig, try this one. U-Substitution. Try that one on your own. See what you get. Right now it's practice. So the first part is rewrite without the fraction. You don't have any roots, so it's just a fraction. Then we have to pick a u. Again, the u that I pick is always the guy with the bigger power. That's, I would say 95% of the time, you're going to choose the guy with the bigger power. We have this guy, and I have this guy that I can choose from. The guy inside the parentheses has the bigger power. So du 12x squared dx, then divide by 12x squared, 1 over 12x squared. So I get dx equals 1 over 12x squared du. Six x squared. Can't move it to the front, so it's got an x with it. X squared. So I leave it there. This is u. Du is going to be 1 over 12x squared. Du. Multiply by x squared, divide by x squared. Those become 1. So now I have 6 divided by 12, which I can move to the front now. The 6 and the divided by 12, I can move over to the front. So you get 6/12 is 1/2. So you get 1/2 times, if I add a power, I get u to the negative 2. Divide by negative 2, which is the same thing as multiplying by negative 1/2. Oops. So I get negative 1/4, move everything back in. Done. Okay. Okay, so the last couple that we have in our notes, there's another trig. There's another And there's an E. I think there's a trig. There's an E. And that's it. So if we have time, I'll give you a couple more, but I definitely want to go through these first because we'll do another trig. So we got a cubed, right? So the first thing that I do with these guys is rewrite them. Because remember, in trig, they write squareds and cubes a little differently. So what this means is sine of x to the third power times cosine of x dx. One of them is going to be my u. One of them is going to be my u. I have two options. I have sine of x and cosine of x. Those are the two functions that I have. So one of them has to be u. Which one? There are ways to do it, but sometimes getting the wrong one is just as good. So let's try this. So the right one is actually sine. But let's say we didn't know that. Let's say I didn't know the right u is supposed to be sine. Sine is supposed to be u. But let's say I didn't know that. Let's say cosine. Let's use cosine. See what happens when we make a mistake. I want you to see what happens when we make a mistake. How do you know it's a mistake? So let's try cosine for u. Derivative. What's the derivative of a cosine? Negative sine, right? Dx. Divide by negative sine. So 1 over negative sine of x, right? So we get negative 1 over sine of x du equals dx. Move-in time. So sine of x to the third power stays. That wasn't u. U was over here. And then du was that guy. Will all the x's cancel out? So this guy is divided by sine, right? This guy is times sine. So this will go down a power, but I still have sine of x squared. I can't go on to antiderivatives if I have x's and u's, right? There's still two sines of x that I can't deal with. That's when you know you made a mistake. That's when you know, oh man, I still have an x here. I still have x here with a u. I should just have u's. I can't deal with that. Then you know you made a mistake. How do you correct your mistake? You go back to where you started and pick the other one. Pick the other option. Okay, I picked cosine. It didn't work. So let me pick sine now. The derivative of sine is cosine. Plug it in. So anywhere I see a sine of x, I'm going to put in a u. So it's going to be u to the third power times cosine of x times now dx. Now I'm going to plug in for dx. dx is 1 over cosine of x du. So now the x's, I have a cosine of x and a 1 over cosine of x. Well, they're reciprocals of each other. So when I multiply them, I just get 1. No more x's. That's when you know you did U substitution correct. There's no more x's. I've moved everything back in. There's only u's. So now I can do u add a power, divide by that new power, so 1/4. Move u back out. Done. Okay. All right, let's try just do the last one, and then if we have some time, I'll give you some other problems to try. Okay, last one, an E problem. Here's the thing with E's. Here's the trick with E's. I'll give you a little tip. If E is a power other than x, if E has a power other than x, the power is going to be U. So instead of e to the x, it was e to the 4x plus 1. The power is going to be u. The only time that doesn't work is if e's power is just x. Okay? So we have two options. I can break them up like I've been doing. All right? So I have two options. I have e to the x and e to the x plus 1. One of those is going to be my u. The other is going to be my, the other is going to stay. How do you know which one? Well, e's are a little tricky because what's the derivative of e to the x? Not natural log. What's the derivative of e to the x? No. It's easier than that. It's easier than you guys think. What's the derivative of e to the x? So let's say I have maybe this is easier. Let's say I have e to the 2x. What's the derivative of that? How do I do the derivative of that? It always starts with itself, right? It always starts with itself. E to the 2x, and then you multiply times the derivative of the exponent, right? So it'd be 2e to the 2x, okay? So what's the derivative of just e then? Just itself. Because the derivative of x is just 1, right? So the derivative of e is itself, right? That's the derivative of e. So with e's, when you're finding derivatives, it's just going to be itself. Okay. So again, which one is it? Which one is it? I don't know. I honestly don't know. So let's try the e to the x. Let's try just the regular e to the x. That's going to be our u. See if that works. The derivative of that guy is e to the x dx. Divide by e to the x. Plug in. So we get e to the x is u times e to the x plus 1 negative 1 power. And then I have 1 over e to the x du. That's my... Will all of the x's, anything with an x, go away? Will this guy and this guy go away? Nope, they won't, right? They're close, but they're not the same term. That's when you know you picked the wrong u. That's when you know, that's the way to know if you picked the wrong u. So it's all right. I'm erasing it since I don't want to confuse you, but don't erase it. Just start the problem over. Just move down a little bit more and start the problem over. Okay, so let's pick the other guy, the guy that we didn't pick last time, e to the x plus 1. What's the derivative of e to the x plus 1? E to the x, right? Same derivative. Divide by e to the x. Plug everything back in. So e to the x is going to stay in the front. Now this guy is going to become u. And dx is going to become 1 over e to the x du. Now, will everything with an x go away? Yes, they will. How do I find the antiderivative now? A little bit of a trick question. We've seen this before. How do I usually find the antiderivative? Add a power, divide by the power, right? This is the only time antiderivatives won't work. It was a while ago, a few weeks ago, but I told you to write this down because we would be seeing it in the future. The only time antiderivatives don't work. Where is it? Where was it? Right here. The only time antiderivatives don't work because we get x to the 0 over 0, right? So if the antiderivative doesn't work because it's the negative 1 power, how do you do that? It's the natural log of x. The natural log of x. So it's going to be the natural log of x plus c. Oh, sorry, the natural log of u, sorry. Not using x, I'm using u. Plug u back in. Done. The antiderivative of anything to the negative 1 power is always going to be natural log of x. Anytime you have a negative 1 power and you're trying to do antiderivative, that's when it won't work. That's when the power rule, add 1, divide by the power, won't work because it's 0. So what do? Give it a natural log. That's how to get around it. Okay? All right, so let me give you at least one more, maybe a few more problems. You should have some space there. I left some space open. Okay, so let's try this one. Let's try this one. Let's see. x plus 1 times e to the x squared plus 2x dx. So another e problem. So, like I told you guys on the last problem, if e has a power other than x, almost guaranteed that's where you're going to start. Almost guaranteed that's where you're going to start. So we have three things going on here. Three things we can choose for u. I can choose this guy. I can choose the whole thing. Or I can choose just the power. And like I said, if you have e to some power and it's not x, more than x, chances are the power is where you're going to start. So the power is going to be my u. Du 2x plus 2. Divides dx, forget about the dx. Divide by 2x plus 2. Substitute. Put u where it goes, put everything else, leave everything else. Will the x's cancel out? I have an x here and an x here. Will those guys cancel out? A little bit of a trick question. Not really a trick, but there you go. You got to factor this guy. This guy I need to factor. I need to change this to 2x plus 1. Then they match. So when I do that, the x plus 1s cancel out. And I get e to the u times 1/2 du. Move 1/2 to the front. Oops. What's the antiderivative of e to the u? E to the u. If the derivative is e repeats itself, the antiderivative is going to repeat itself too. So I get 1/2 e to the u plus c. Put u back in. Done. Like I said, almost always, if e has a power other than x, that's where you're going to start with your u. That's going to be the u. Okay? Let me give you one more. We'll be done. One more. I'm going to give you another trig one. One more trig one, and then we're done. Okay, so we have x times sine of x squared. So the whole thing is not squared, just the angle. Light it up. X in yellow. The orange, which is all of it, x sine of x squared, or just x squared. Go back to the very, very, very beginning of the lesson. We always said look for the, where did we say at the very, very, very beginning? Look for the the most inside part, the innermost part. Well, the innermost part that I can see is x squared. It's the angle of sine. That's probably where I would start. Is it the correct answer? I don't know. We're going to find out. But that's probably where I would start, the innermost part. Once I rewrite it, I can't really rewrite this guy. So once you do that, look for the innermost part. Okay, plug everything back in. X times sine of u times 1 over 2x du. The x's are going to cancel out. So I'll have 1/2 sine of u du. The antiderivative of sine is negative. Was it negative cosine? No. Is it negative cosine? Okay. So it's negative cosine. So I'll move the negative to the front. Cosine of u plus c. Okay. We have, like I said, we have one more lesson left, which will start on Wednesday. The easier or the better you get at U-substitution, the easier that lesson's going to be, because what we're doing on the last is pretty much this. We're just doing it with bounds, which we call bounds. That part's not bad. So the more you practice on this, the better you get on this, the easier that lesson will be. Okay, we'll start that on Wednesday. Tomorrow I'm going to give you a practice on this, let you practice, and then go from there.